Okay, in this section, I think we will summarize the property of the quadratic function. We actually use those properties a lot here and there, but in the section 4.3, there's a summary. Quadratic functions and their properties. Okay, quadratic function. What is a quadratic function? Ax squared plus bx plus c is a quadratic function, where a, b, c are real, and a is not equal to 0. Real means that they are constant numbers. If a is 0, you don't have the square term. It's a linear function. Okay, so this is a quadratic function, and the domain is a set of all real numbers. Okay, the domain is a set of all real numbers. That's a definition. You can create your own quadratic functions. And first, we can get the simplest quadratic function, like y equal to x squared. Y equal to x squared. Y equal to x squared is a parabola. Remember that what this is. What parabola is this? What parabola it is? It's like this, and we know that in the parabola discussion, the standard form with the focus on the y-axis p, this is x squared is a 4py. So here, if y is x squared, I mean in the quadratic functions we write y equal to x squared. In the parabola discussions, we like to write x squared is equal to 4py. It's just a different topic. We use different formula, different form. Okay, so it means p is equal to 1 over 4. So this is a y equal to x squared. Its graph is a parabola with p equal to 1 over 4. This is p, the focus, and directrix is equal to y equal to negative 1 over 4. Okay, so quadratic has the graph a parabola. You can determine the focus and the directrix based on this coefficient of y. Y is 1. Okay. Okay. And this is the simplest one. Once you get this, you can multiply. You can multiply x squared by arbitrary positive number. Give it a coefficient, right? So when we give it coefficient, remember it's like 3 times fx if this is called fx. If this one is called fx, it is 3 times fx. Then when you have 3 times fx, you're going to stretch it along the y direction, vertical stretch. If you have 1/3 x squared, which is 1/3 fx, you're going to vertically compress the graph. So either way, the graph of y equal to ax squared, here a is greater than 0, is a vertical stretch or compressed version. So it is more or less like this. And when you have something like this, what is the position of a focus? Be careful. This one, when you want to find the position of focus, you have to write x squared is equal to 4py. So from here you get x squared is 1 over ay, and it's 4 times 1 over 4a times y. So p is equal to 1 over 4a. Okay, so be careful if you want to discuss the geometry of the parabola. Write x squared equal to something of y, some coefficient of y. Okay, don't write y equal to some coefficient of x squared. Okay, so that's the general graph of y equal to ax squared. And here we require a to be positive. If a is negative, remember you have the vertical reflection, because negative means you put a negative sign for the fx, like the y equal to negative x squared. It's a vertical reflection, so it's this direction, and this one is called opens up. The graph opens up. This is called the graph opens down. Okay, so for the quadratic function, these two type of quadratic function, you will have opens up case and open down case. And for these two, I'm talking about just these two. For these two cases, they both have the axis of symmetry, y-axis. They both have axis of symmetry, y-axis. Okay. And this is the simple form. The thing is that we will have the standard form, like ax squared plus bx plus c. If that happens, how do we find the vertex, the focus, and the axis of symmetry? Assume we have something like this, the quadratic function 2x squared plus 8x plus 5. So how do we do it? We are going to complete the square for x. Okay? So what is a complete square? The complete square is the following. First, we factor out the coefficient 2. Leave this alone. Leave the constant term alone. You factor out 2 from x squared and x term. And then again, x squared plus 2ax plus a squared is equal to a plus x squared. So here x squared plus 2ax. So 4 divided by 2, you get a equal to 2 also. Okay, so a is equal to 2, a squared is 4. So you put 4 here. You put 4 here with the coefficient 2, you actually add 8. Okay, so when you put 4 here with coefficient 2, you add 8. You add 8, you subtract 8. Then this is still the same thing. Okay. And then you call this as y equal to it. Y equal to it, then you move this negative 3 to the left side. Okay. What is a vertex? What is a vertex? Sorry. Let's move one more thing. If we just want to remember that x minus h squared is equal to 4py minus k. This is the parabola opens up with a focus at 0p. The parabola opens up with a vertex with a focus at with the focus distance with the distance between the vertex and the focus equal to p. Okay. For this formula, it's x minus h, y minus k. So the vertex is -2 and -3. The vertex is -2 and -3. And if you want to find the p, you have to divide 2 for this equation. You divide the equation by 2. So you get 1/2 and then you write like 4 1/8. So you get p is equal to 1/8. Okay, so if they ask you to find the focus, this is related to the focus. How do I do it? Okay, if you're asked to find the focus, you need this p. P has to be computed by this way. X squared term cannot have other coefficients. Okay, so how do I do it? Let me try to sketch it. So it's -2, -3 x 1 2. This is -2, -3 1 2 3. Okay, and it's x squared equal to positive y, so it opens up. Okay, x squared positive y, it opens up. If we do not solve it, so we just write this way, draw it this way. And the axis of symmetry, is x equal to -2. This is x equal to -2. The vertex is -2, -3. So now, what is where is the focus? Focus has a distance. The distance between the focus and the directrix is the distance between the focus and vertex is 1/8. It's opening like this, so it's up. It's like this position. So it's a -3 plus 1/8 plus 1. It's a negative 23/8. So the coordinates of the focus is -2, -23/8. You go up 1/8 unit. You go up 1/8 unit, right? The focus is always inside the opening, inside. So this is a focus. This is vertex. This is axis of symmetry, and it's a sketch of the graph. In the problem, okay, so all things depend on the question. If the question only asks you to find the vertex and the axis of symmetry, you stop at here. You stop here. You complete the square. You move this term to the left side. You can determine the vertex. Okay, and from the vertex, actually, because it's vertical, so x equal to -2 is the axis symmetry. This term comes from the x coordinate of the vertex. For the parabola, the axis of symmetry is x equal to the x coordinate of the vertex. Okay, so this is a detailed computation about the vertex and the focus. We can do the similar computation to get the formula. Okay, so let's do what we have done in the abstract way. So assume we have y equal to ax squared plus bx plus c. It's abstract, like 2x squared plus 8x plus 5. And what we did, we factored out the coefficient of x squared and leave c alone. And we divide the coefficient by 2, we get a. So 4 over 2 is 2. This 1 over 2 is b over 2a. So this is our, this a, not this a. Okay, this is our constant number. And we add its square. We add its square here times a. We're going to subtract it. Remember that here there's times a. This number with the coefficient. That's actually a number you add in the first part. Okay, and then this is x plus b over 2a square. And here it's a c minus b squared over 4a. Here is a 4a squared. Here you have a. You cancel one copy of a, you get b squared over 4a. And you continue the simplification. You get this. Okay, this number, if you have the computation, this number is equal to -3. And remember, this is a y. If you move this y to the other side, I write a minus instead of a plus. So what is the vertex? The vertex is negative b over 2a. This is x coordinate. 4ac minus b squared over 4a. This is y coordinate. Here is already minus sign, so you don't change anything. Okay, this is a vertex. The axis symmetry is x equal to negative b over 2a. X is equal to negative b over 2a. Okay, so that is the abstract computation with the coefficients a, b, and c. Right? So it's exactly the same steps as a first example. And when you have the vertex, you have axis symmetry. Then how do you sketch it? If a is a positive, you sketch it like this. If a is negative, you sketch it open down. Okay, so a is here, a is a coefficient. A greater than 0, the graph opens up. A less than 0, the graph opens down. And you have the axis symmetry, you have vertex, everything. And if they ask you, again, if they ask you the focus, you have to divide A to the left side and use that 4py to determine the focus. Okay. And also from this graph, you see what? If it's open up, this vertex is the lowest point, right? If it opens up, if the graph opens up, this is the lowest point, the bottom point. If the graph opens, this is opens up, the lowest point. If the graph opens down, it's a peak, it's a highest point. Lowest point, absolute minimum value. Highest point, absolute maximum value. Right? So a greater than 0. A greater than 0, then the vertex is a minimum point. Minimum point, then the corresponding y coordinate. The corresponding y coordinate is the absolute minimum value at negative b over 2a. Okay, so when a is greater than 0, the vertex is a minimum point. The corresponding y coordinate is the absolute minimum value at the x coordinate. The minimum value happens at the x coordinate. Okay, and if a is less than 0, the vertex is a maximum point. 4ac minus b squared over 4a is the absolute maximum value at negative b over 2a. Okay, so that's a maximum value. Okay. So that's the discussion, and that's what we can read from the graph. Now let's see the example. We have this quadratic function. Then let's check the vertex. Vertex, we need negative b over 2a. What is a? A is negative 3, 2a is negative 6, b is 6. 4ac minus b squared over 4a. 4ac, okay? 4ac minus b squared over 4a. So it's negative 12 minus 36 over negative 12 is positive 4. It's positive 4. Right? Okay. Here, there's one thing. This value, it is actually equal to 4ac minus b squared over 4a is actually equal to the evaluation of a function at negative b over 2a. If you don't remember this complex formula, how do you find the corresponding value? You evaluate negative b over 2a, you get 1, and then you put 1 in this formula. So you see this negative 3 times 1 squared plus 6 times 1 plus 1. Negative 3 times 1 squared is negative 3, plus 6 plus 1 is equal to 4. Same thing. Okay, So if you can memorize this formula, you directly apply A, B, C and get the value. If you don't memorize it, it is the value at the negative b over 2a. That's, you see here, this is ops value at this point. So either way, you can use either of them to determine this value. Okay, once we get this 1 and 4, the vertex is 1, 4. The axis of symmetry is x equal to 1, x equal to the first x coordinate, and the graph opens down. The absolute maximum value is 4. This is the absolute maximum value is 4 at x equal to 1. At x equal to 1, you get absolute maximum value. See, you get 1, 4, then you can read all these problems. And the graph opens down because of a is equal to negative 3. Except this sentence, those vertex of graph, axis of symmetry and absolute maximum value all depend on those two evaluations. Technically, you only need to evaluate negative b over 2a, and based on this quantity, you can find the y coordinate and the rest of the statement. Okay. Okay. And now let's check let's focus on the graph open up case. So assume well, let's see. No, it's not. So far we don't do this. We just state the x-intercept property. X-intercepts of quadratic functions. Remember, we actually use this a lot of times. The discriminant is positive. The graph of fx equal to ax squared plus bx plus c has two distinct x-intercept. It has two distinct x-intercepts, so it crosses. It means the graph crosses the x-axis in 2 points. Okay. This one corresponds to situations. It can be like this when it opens up, or it can be like this when it opens down. Okay. When the discriminant is equal to 0, then the graph has just one. The graph of fx equal to ax squared plus bx plus c has y and x intercept. So it touches the x-axis in one point. In one point. This is a greater than 0 case. This is a less than 0 case. Okay, so the second situation, it is like this. So it can be this way, or it can be this way. So when discriminant is equal to 0, so we have those two cases. When discriminant is less than 0, the graph has no x-intercept. It has no x-intercept, so it does not cross or touch x-axis. If it does not cross or touch x-axis, or let me put it on the same. It's like this. This is x greater than 0. And like this. If a is greater than 0, or if a is less than 0. A is great. This is a case when a is greater than 0. This is case when a is less than 0. Okay, so that's all the classifications, and that's, again, you can find the corresponding absolute max and absolute mean. Okay, and also you can see the where the functions where the solution set of inequalities. For example, for this case, less than 0 is between those two vertices, between those two x-intercept. Greater than 0 is either on the left side of a smaller x-intercept or greater than the bigger x-intercept. And here it's greater than 0, it's between them. Less than 0 is on two sides. And here it's always greater than or equal to 0. This one is always less than or equal to 0. This one is always strictly greater than 0. This one is always strictly less than 0. Okay, so if you can memorize those 4 graphs, you can quickly determine the solution set of the inequality. Okay? Okay, so let's try to do the problem. Let's make some example. The example in the textbook still use negative 3x squared plus 6 plus 1. The solution is not integer. It's difficult to locate, to plot. So let's assume we have fx equal to what it is, x squared. Put a negative. X plus 2. Okay, let's try this. Let's try this one. Yeah, it works. Okay, for this one, what is the vertex? Negative b over 2a. Negative, negative, 2a, 2a, b. So many negative signs, a negative 1/2. Okay, negative b over 2a, negative 1/2. 2a. I even don't trust myself because I make so many mistakes. Negative b over 2a is like this, and 4ac minus b squared over 4a. 4a, 4ac minus b squared. Okay. Negative 4 is negative 8 minus 1 is negative 9. It's a 9 over 4. Let's try the other way. So f of negative 1/2 is negative 1 over 4 plus 1/2 plus 2. So negative 1 over 4 plus 1/2 is positive 1/2. So 1 over 4. 1 over 4 plus 2 is 9 over 4. Okay, that's correct. So the vertex is negative 1/2 9 over 4. That's the vertex. The axis of symmetry is x equal to negative 1/2. Okay, and then let's check the x-intercept. X-intercept is the solution of a quadratic equation. Okay, so here in this section we talk about quadratic function, and we already did the discussion about quadratic equation. This is quadratic equation. I multiply everything by the two sides by negative 1. I prefer the positive x squared coefficient. And then we can factor it. We will get x is negative 2 or x is positive 1. Okay, so there are two solutions. There are two solutions. Then the graph the graph of the quadratic function crosses x-axis at negative 2 and 1. Okay, now let's try to graph it. 1, 0, negative 1, negative 2, 1, negative 1, negative 2, 1, 2, 3. This is negative 1, negative 2, negative, up, 9 over 4. 1, 2, 3. 1, 2, 3. This is 1/2. 1/2. 9 over 4. 9 over 4 is possibly here. 9 over 4 is here, and it opens down. It opens down because of a negative x squared. So the graph is like this. The axis symmetry is here. Okay, so that is a graph of this quadratic function. Opens down through those two x-intercept. The vertex is this place. And you can also observe that the axis of symmetry, those two x-intercept is symmetric about axis of symmetry. How do I get it symmetric? You see, this is a 1. It's a negative 2. The average value is negative 1/2. That's exactly this. And that's also the geometric meaning of axis of symmetry. It's a symmetric. Those 2 points are symmetric. Okay? So negative 1/2 is a midpoint. The average value of negative 2 and 1. Okay. Let's see other examples. This example, you have two x-intercepts. Let's check if we have fx equal to x squared minus 6x plus 9. First, let's find the axis, the x coordinate of the vertex, negative b over 2a. negative, see, negative 2a, a is 1, 2, b is negative 6. Again, a, b, c all contain the sign. Okay, so negative b over 2a is a 3. Now f3 is like 3 squared minus 3 times 6 and plus 9. 9 plus 9, 18, minus 18, 0. So f3 is equal to 0. So the vertex is 3, 0. The axis of symmetry is x equal to 3. The graph opens up. The graph opens up because here's coefficient is positive. And then let's check the x-intercept. You check the x-intercept, you see this is exactly x minus 3 squared. This is exactly x minus 3 squared, so x is equal to 1. X equal to 3, there's a 1 x-intercept. There's 1 x-intercept. There is only 1 x-intercept. The graph touches x-axis. And the reason I put 1, 2, 3, 4, 5, 6, 7, 8, 9. The reason I label this 9 is that when x is 0, its corresponding y-intercept is 9. When x is 0, this is 0, this is 0, you only have 9. So yeah, your graph will be like that. It's not a straight line. You have to make it curved. And it opens up, so it's this way. Okay, so that's the graph of the parabola. That's a graph of the parabola. It touches x-axis. So this graph is all above x-axis except this vertex. The vertex is on the x-axis. So if you talk about the inequality less than 0, then there's no solution. The inequality greater than 0, everything except the vertex. The inequality greater than or equal to 0, the set of all real numbers. Okay, let me say it again. If you're talking about this quadratic function less than 0, if this quadratic function less than quadratic function less than 0, no solution. This quadratic function less than 0, no solution. No graph up below the x-axis. If this quadratic function greater than 0, everything except this point. This point, the quadratic function is not greater than, it is equal. Okay, greater than 0, everything except this point. If the quadratic function greater than or equal to 0, everything. So okay, so that's our possible situations. Okay, so the next case for this classification is that when the discriminant is less than 0. So this example corresponds to the discriminant greater than 0. You have 2 intercepts. And this example corresponds to the discriminant equal to 0. There's only 1 x-intercept. And the next one, you will have the discriminant less than 0 case. So you have y equal to 2x squared plus x and plus 1. 2x squared plus x plus 1. So if we're trying to find the vertex, axis, symmetry, graph, and graph it, x-intercept, so we do the similar thing. Negative b over 2a. Negative b over 2a is a negative 1 over 4. And 4ac minus b squared over 4c. 4ac minus b squared over 4 over 4a over 4a. It's 8 minus 1, 7. 4 times 2, 8. So the vertex is negative 1 over 4 and 7 over 8. 7 over 8. The axis symmetry is x equal to negative 1 over 4. And then you check the discriminant. B squared minus 4ac is 1 minus 4 times 2 times 1 is negative 7, less than 0. The graph does not cross or touch x-axis. Okay, does not touch or cross x-axis. Let's try to sketch it. It's negative 1. Because I have negative 1 over 4, I don't need very large. Negative 1 half. This is negative 1 over 4. 7 over 8. So 1 is here. 7 over 8 is more or less here. So this is vertex. And opens up. Yeah, I forgot to mention it. Opens up. So it's this way. This way you can see the graph is totally above x-axis. Okay? And actually it has no way to cross it. If you cross it, this bottom point should be below it, below the x-axis. If your the graph opens up. If you want the graph cross x-axis, your bottom point should be below it. Then it's like you pull it down, it has a x-interception. But now it's above x-axis. There's no way to get x-intercept. Okay, so next, let's talk about something to determine the quadratic function based on the geometric information. Y minus k is equal to a times x minus h squared. This is one of the formula we had. Let me figure it out. Where is it? Here, this one. See, this is one of the formula we figured out. This one. Here we write a negative b over 2a and this complex formula as k and h. So this place we just use h and k to represent them. Those are the xy coordinates of the vertex. A does not depend on the vertex. Well, of course, A is contained in the vertex, but you cannot directly compute it from it. Okay. The thing is that sometimes we have the vertex and we have a point on the graph of the quadratic function. How do we determine the equation? Okay, so from this formula, we normally move this k to the right side. You can also see this one. Okay, so That's the formula, the starting formula. Determine the quadratic function whose vertex is 1, -5 and whose y-intercept is -3. Okay, so we know the vertex, we know one point on the graph. Y-intercept is also a point on the graph. Okay, so once you know the vertex, the graph, the equation becomes, not equation, the function becomes y equal to a times x minus 1 squared and plus k. Okay, so here in this formula it's always y minus k, x minus h, but if you move the k to the right side, it's not minus, it's plus. Okay, so it's plus -5. Then we have to determine this a. You see here, this a is independent of the vertex. This a independent vertex. So in order to determine a, we need to use the second condition. The y-intercept is -3. What is y-intercept? f0. So if you get this is fx, f0 is -3. The y-intercept is f of 0. Okay, f of 0, what is f of 0? A times 0 minus 1 squared and minus 5 plus -5 minus 5. 0 minus 1, -1. -1 squared is just 1. So -3 is equal to a minus 5, so a is 2. So the equation, not the equation, the function is y equal to 2 x minus 1 squared minus 5. X minus 1 squared minus 5. If you want to graph it, let's graph it. One, 2, 3, 4, 5. Okay, this is -1, -5, -1, -5. Positive 1, positive 1, -5. Positive 1, -5, and y-intercept is -3. This is -3. It's the graph opens up. It will be like this. This is a graph. Okay, this is positive 1. All right. I mean, I label positive 1. Okay, let me come down. Okay, so this is a graph, and this is a way to determine the function based on the vertex and another point, one other point. So if you have a vertex and you have an extra point, you should think about this kind of expression. If you have the ax squared plus bx plus c, you should be able to determine the vertex, determine the axis of symmetry, and determine the x-intercept, and then graph it. So either way, you need 3 quantities: x-intercept, y-intercept, some certain the values, because by this way you can determine ABC or AHK. You have 3 variables. And yeah, one more thing, I just mentioned them quickly. If a is greater than 0, then this is a 4ac minus b squared over 4a. Remember that this is a minimum value. If a is less than 0, this is 4ac minus b squared over 4a is the maximum value. You can read the example 7 on page 296. We just use those formulas to find the maximum value or minimum value. We mentioned this before, but we didn't do the computation. But this is the true thing. And also there's a summary on the same page. And this is an important page, and read it and try to understand it. If you have a question, send me email. Okay, so we finish this video.